Deadly Ferris wheel question. Students send me this kind of question all the time, so I thought I'd just make a YouTube video on it, especially because of this part D. Students do not know how to find the time taken for a Ferris wheel to complete certain numbers of revolutions. So we'll get to that in a second. But part A, just as important. Express 10 cos theta minus 3 sine theta in the form r cos theta plus alpha. Now, one thing to clarify here, guys, you do not get marks for proving or showing the addition rule. I have some students who I teach and they use my method, and many other people do this method as well. I did it in my A-levels. When they use this method, their teacher does not give them full marks. That is your teacher's fault. They do not know how to mark papers properly. So look at any mark scheme. They do not give you marks for doing the addition rule. So to find r, you simply do Pythagoras to the coefficients. So r is the root of 10 squared plus the other coefficient 3 squared. Now I didn't write it down, but the question wanted you to keep r exact, so that's 100 plus 9. So we just keep it as root 109. Now the next thing you guys need to check to find the angle alpha is that the first trig function matches this trig function. Cos, cos. Good. So to find alpha, you simply do inverse tan of the second number divided by the first, 3/10. And now, again, I didn't write it down, but the question wanted you to do this to two significant figures. And you can see here it's in degrees. So inverse tan of 3/10 is 16.70. Now, if it asks for 2 decimal places, you must include the 0. You'll lose an accuracy mark if not. 3 marks. 1 mark, 2 marks. Well, 1 mark, 1 mark, 1 mark. Okay? Now, the next part of this, which is the juicy part of the question, is saying Alana is modeling the height above the ground. I don't know if you guys can see. Alana is modeling the height above the ground of a passenger of a Ferris wheel on, or of, I don't know, on a Ferris wheel using this formula, where h is the height above the ground in meters at time t minutes. So Hockey is going to put the photo of the Ferris wheel somewhere. Yeah, so you can see what h is. H is the height above the ground of the passenger in meters, and it is at time t minutes. Find h max and the value of t when this first occurs. We're trying to find the maximum value of this function. Okay, 12 minus 10 cos 30t plus 3 sine 30t. This looks very familiar. We did it in part A. Cos and sine have maximums in different places. Okay, so we need to rewrite this as one trig function so that we can only observe, one trig function only. Okay, so we do that using what we did in part A. The only difference is that this was a positive 10, this is a minus 10. That's a minus 3, that's a plus 3. Easy. All we do is we factorize out a minus. Okay? If I factorize out a minus, it'll become 12 minus bracket 10 cos 30t minus 3 sine 30t. So basically, using part A, it's just the negative of this. Okay, so what's it going to look like? H is 12 minus what we got in part A, which was that r cos. R was root 109 cos. Now, theta has changed. Theta has changed to 30t. So it's 30t plus alpha. So 30t plus this 16.70 degrees. All right. So we're going to find h max of this. How do I find its biggest value? Well, think about the cosine function. The cosine function fluctuates between 1 and minus 1. Those are the extreme values of cos, right? So you're thinking, does cos need to be 1 or minus 1 in order to maximize this function? Well, if cos is 1, you'd get 12 minus root 109. And if cos is minus 1, this changes to a plus. And that's what we want. So when that's minus 1, it becomes a positive root 109. So h max is 12 plus root 109. Okay? If they want you to round that, they will say. I know for a fact, though, just based off memory from the question, t, the value of t they wanted was to two decimal places because we did the same with this angle. So how do we find the value of t really quickly when h is maximized? What students do is they sub this back in, rearrange for cos, inverse cos, etc. We do not need to do that, guys. That is super long. All you need to do is understand the cosine function. We wanted it to equal -1, right? The cosine function does this, and its minimum point is at 180 degrees, okay? So you just need to picture this in your head, okay? I've written pi, sorry, that's in radians. So all you're doing is you're just saying this needs to equal 180. So you have 30t plus 16.70 is 180 degrees, and then we're just going to rearrange for t, which in my calculator I got 180 minus 16.7 divided by 30 gives me about 5.44, and that's minutes. Cool. Part C. Calculate the first time the passenger is 18 meters above the ground. Okay, so that's easy. Yeah, so we're just equating h to 18. Yeah, so we're going to have 18 is 12 minus root 109 cos 30t plus 16.70. That's going to come here. This is going to come here. 12 minus 18. 18 minus 12 is 6, so minus 6. And then we're going to divide by root 109. So I'm going to get cos of 30t plus 16.70 is minus 6. Yeah, so then we can divide by that coefficient, root 109. Now, they only wanted the first value, right? So they wanted the first value of t that this happens. So literally all you're doing is you're inverse cosing that. Then you're going to minus 16.7 and divide by 30. And that's going to be the first value, okay? Just to kind of describe what's going on here. In my calculator, inverse cos of minus 6 over root 109 is 125 degrees. Now, for cos, to work out the secondary value, you do 360 minus. 360 minus 125 is bigger than 125. And then you add a minus 360. There's not going to be any other positive cos function. So this 125 degrees, when you do inverse cos of this, is the first value. So I'm going to minus 16.70. I'm going to divide that by 30. And I get 3.61. And they also wanted this to two decimal places. Minutes. And now we get to what all students ask me about is part D. Determine the time taken for the Ferris wheel to complete 2 full revolutions. I'm going to make Hokia put the picture here so you guys can see it the whole time. All right. So we want to figure out how long does it take for the, right now there's no picture here for me, so I'm just pretending it's over there, innit? So we're trying to figure out how long does it take to cycle 2 times, okay? Now, what do students do? Generally speaking, what they do is they take this value, they either times it by 2 or by 4. Some of them, they take this, sub in, yeah, they find h max, that time, which is this. Then they do the h minimum, find that time, subtract them, yeah, because that tells you the time to go from the lowest point to the highest point. They times that by 4. Guys, that would not be worth 2 marks. There is much quicker ways to do this. If you study physics, you will know this word. It's known as the period of a graph, okay? So just to give you guys a bit of background behind the period of a graph, the picture, which I hope is still here, over here, the Ferris wheel, right? We are modeling it using a cosine function. And a cosine function just cycles every 360 degrees, right? Which means the motion of this Ferris wheel is cycling every 360 degrees if it wasn't for this, okay? So if we think about the period of a graph, I'm just going to give you guys some theory here. Let's look at the sine graph, the cos graph, and then I'll just explain the tan graph verbally. The period of a sine and cos graph is 360 degrees. Okay? For the tan graph, it would be 180 degrees. It cycles every 180. Okay? Now, we just need to think about how does the period get affected for different functions. For example, here's my cos graph. Y equals cos of t. All right? What happens if I just put a 2 in front of the t? What does that do? That is going to compress all the x values by a scale factor of 2. The 360, we would end up dividing it by 2. Okay? What happens if that's a 3? It would be 360 divided by 3. The period will decrease by a scale factor of 3. What if it was a half? Well, you wouldn't be dividing by 2, you'd be dividing by a half, which would actually multiply it by 2. So it looks like wherever the coefficient of t is, if I call it alpha t, the period, 360, we would just divide by that alpha. Okay? But what happens if I, add something over here? So let's just go back to our 2t. If I had 2t plus, 30 degrees. Okay? Yeah, that 2t is dividing by 2. But that 30, is it affecting the period? Well, no. This is a translation. It's just taking the graph and shifting it to the left. Okay? In fact, it will be by 15 degrees because we've already done this compression in the x-axis. You'd factorize out 2, you can see the 15. Okay? So it's a 15-degree shift. It does not affect the period. So these pluses and minuses do not affect the period. And this is all we need to know. That the period, or the time for one complete revolution, is 360 divided by the coefficient of t. Okay? So, how do we write this? In this case, our period, let me get rid of that. My period is 360 degrees divided by t. Okay, that coefficient of t. I didn't really need to use capital T there. I'll use something else. I'll use alpha. All right? So for us, our coefficient of t is 30. So for us, it's 360 divided by 30, boom, boom, 12. Okay? 12 minutes for one full revolution. So our 2 revs is 24 minutes. Okay? And that's how we answer that. That's 2 marks worth of working, isn't it? Obviously, I had to explain to you about the period of the graph and how that helps us here. And that, guys, is how we answer all of these questions for a really solid trig question. So, guys, if you learned something today, hit the like button, subscribe for more, head to my Lung Gang Reddit channel if you want to submit questions and discuss more things maths. And if you're interested in my maths courses, there is a link in the description. I also have Easter revision courses happening in April. We're running some cool discounts. So if you guys are interested, again, all the details in the description. I'll see you guys in the next one. Nice.